Hello everyone, and this is a topic from heat exchangers. This is the last topic of fourth unit, that is NTU method, number of transfer units method. This method is used to find out the unknown temperatures of the hot and cold fluids in the heat exchanger. Now coming to the topic, to determine inlet or outlet temperatures for a particular heat exchanger, the NTU method is employed, where the heat exchanger effectiveness epsilon is used. What is effectiveness? We have seen this effectiveness topic during fins. Effectiveness is equal to actual heat transfer per maximum possible heat transfer. And what is actual heat transfer? We know with respect to the temperature difference of hot fluid inlet and outlet temperatures, and also cold fluid inlet and outlet temperatures, it is given Q actual is equals to mass flow rate of hot fluid. CPH stands for specific heat at constant pressure for hot fluids. TH1 minus TH2, temperature difference between the hot fluid inlet and outlet of hot fluid, and it is also equal to in the same terms of the cold fluid. Now we have one more term, MHCPH. We call this as hot fluid capacity rate, and MCCPC is cold fluid capacity rate. It can be a C minimum or C maximum. I will tell you what is C minimum and C maximum. C minimum, C maximum. Suppose if we have found out CH and CC, out of these two, the value of CH and CC, whatever, if it is greater, CH is greater than CC, then we can call CH as C maximum, and at that time CC will be the C minimum, and vice versa. Now for Q maximum, temperature difference should be maximum. C is equals to Q by delta T, where C is equals to C minimum. When temperature difference is maximum, C will be the C minimum, and it is given by Q by TH1 minus TC1. So for Q maximum, one second, it is C minimum into TH1 minus TC1. That equation we have seen during LMTD, logarithmic mean temperature difference. We have already seen it. Now effectiveness is given according to this formula, that is Q actual by Q maximum. Q actual is CH TH1 minus TH2 by C minimum TH1 minus TC1, and in terms of cold fluid heat exchange between the cold fluid, it is CCC TC2 minus TC1 by C minimum TH1 minus TC1, and effectiveness is calculated by using this formula. Now we will apply this NTU method for parallel flow heat exchanger and parallel flow heat exchanger, as well as counter flow heat exchanger. When we go through parallel flow heat exchanger clearly, and the same thing can be applied for counter flow heat exchanger. Now let us see for parallel flow heat exchanger. dq is equals to u dA Th minus Tc, and you must go through the graph for parallel flow heat exchanger, should be very clear, and according to that we will write down the expressions for an elemental area. We will consider an elemental area dA. With respect to that, we will take dq expressions in terms of dTc or dTh, as we have discussed this earlier during LMTD, and we will write the expressions for dTh dTc, which is equals to minus of dq by ch and dq by cc. Now further on continuation, then we need to integrate the term to get integral, we need to integrate it, and we will get the term for temperature differences. See this, Th2 minus Tc2 by Th1 minus Tc1 is equals to e to the power minus Ua by Ch into 1 plus Ch by Cc, and epsilon, that is effectiveness, is equals to the from the basic formulas, and we need to substitute this Th2 and Tc2. These two are unknowns. This is what we need to determine from NTU method. When you know this effectiveness, when you have calculated this effectiveness, now you can find out what is this Th2 and Tc2. These two are unknown temperatures. Now then it is the continuity for, it's a continuity. You just go through this expression. It is 1 by Th1 minus Tc1 into Th1 minus Tc1 minus epsilon C minimum into Th1 minus Tc1 into 1 by Ch plus 1 by Cc, which is equals to exponential form for minus Ua by Ch into 1 plus Ch by Cc. Now we will write the expression for effectiveness again here, and if now the question comes here, what is C minimum and C maximum? In that case, there are two cases, C minimum and C maximum. If CH is C minimum and CC is C maximum, the first expression for effectiveness can be used. And if CC is less than CH, where CH is C maximum, now CC is C minimum, effectiveness will be 1 minus e to the power exponential, that is e to the power minus Uj by C maximum into 1 plus C max by C min, whole thing divided by C minimum into 1 by C max plus 1 by C minimum. Now here Ua by C minimum or Ua by C maximum is a dimensionless expression called as NTU, number of transfer units. Again we will go back, Ua by C max in both the expressions for effectiveness. Here we got Ua by C minimum or Ua by C maximum. They are known as a dimensionless expression, which is called as NTU, number of transfer units method, and this method is known as NTU method. C minimum, second point, C minimum by C maximum is second dimensionless expression capacity ratio. We call this as capacity ratio, capital R. It is indicated with capital R, and the overall expression can be written as epsilon is equals to 1 minus exponential form minus NTU 1 plus R divided by 1 plus R, where epsilon is effectiveness and expands, exp stands for exponential, NTU number of transfer units, that is given by Ua by C max or Ua by C minimum, and R is a one more dimensionless capacity ratio, C minimum by C maximum or C maximum by C minimum. And in the same way we apply the thing for counterflow heat exchanger also. Same, we will consider an elemental area dA and we will write the expression for dQ with the small temperature differences dTH or dTc, and the same integration can be done, same thing, integration can be done, and under again we will get the conditions for Tc2 and Th2 in the terms of effectiveness when this effectiveness is coming into picture, and again we will write the expression for effectiveness is equals to 1 minus exponential form for of minus NTU into 1 minus R by the same thing. Now again and these are the conditions. Some cases are there, case 1, case 2, and when you go through this you will understand what is NTU method, and almost all the formulas are available in our data book, and we have the problems. Just go through few problems that I have given in the lecture notes, and when you understand this, when you practice this twice, then only you will understand. and thereby we have completed our fourth unit. Thank you.